Hello, you can't see me, you can see our students. We only one here. This is our classroom.
你好，老师。
Hello, 你好。Now we begin to color first, okay? For first one, the first one.
Present 老师。It's me.
Second one, 6210. Second one, maybe not here. Third,
I'm here, Luffy.
Okay, next, 任北。任北，1219。Hello. Next, 6211。
Present,老师。
Okay. Next, 1218。
Yes, teacher.
Okay. Next, 伊利。
I'm here, miss.
Okay. Next, 法西木。
Present, 老师。
1214。Okay. Next, 1213高山。Hello，高山。
老师。
OK， 1209。Hello， 1209。1209。Next, 萨贝特。
Present.
OK。Next, 6207。Where are you? 6207。This one, 1220。
Present, miss.
Next, 1207。OK， 艾特。
I'm here, miss.
Next, 1206。
I'm here, teacher.
OK。Next, 1210。
I'm here, teacher.
Next, 1204。1204。Next, 萨基布。
Present, 老师。
王安民。1203。1203。6212。Hello, this one. This girl.欧舒文。
I'm here, teacher.
蕾蕾
高老师。
，OK，1201，爱默斯，OK。Next，
Present,
1216
Miss. Present.
，Next 1215
I'm here, miss.
，OK，Next 1202 ，OK，Present。Next 6203
高老师。
，OK， 6204
高老师。
，OK， 6208 ，Hello， 6208 1201 ，OK，Next 6209 ，Next 1212
Present, teacher.
基朗、于连。OK, we check it. 6210 Hello, this boy. 6210 OK, absent. 1219 Hello, this one.
Hello, Lausi, can you hearing me? My student ID is 210.
This one.
Yes, yes.
Okay, 1219 19. This one. This one. 1209
Teacher, I'm here. I'm here, present teacher. 209. Yeah. Thank Laushi.
207 207 Here. 204 204 Not here. 203
I'm present. Present teacher.
Okay. Next. 212 212 212 This girl. 208 208 209 209 Jilang Yulian. Okay, we end our broker and begin our class. I went to change the station, whether you are here or not. Okay, first we review the important part we have learned last time. We learned the slope of a straight line. For example, this is the straight line through point P and Q. We have P, its coordinate is x1, y1, and Q coordinate x2, y2. Do you remember how to calculate the slope of this straight line? Slope M is equal to y2 minus y1 over x2 minus x1, right? And then can you write, this line through x1, y1, and now can you write the equation? Equation of this straight line. Oh, we know this is point slope 4. Can write the point slope form. Yeah. We write, for example, we have a fixed point is x1, y1. This is the fixed point, and now the equation of this line is equal to the equation y2 y2 what? Is this right? Hello? Is this right? No. Hello, this is right? Hello, student online, can you hear me? This equation. Students in our classroom told the equation of this form. Yes, it's right. No, the equation of this straight line is this form. True or false? Maybe you can. True. Maybe you can answer me directly. No, this is false. We know the equation of this straight line, the point slope form we write like this: y minus y1 is equal to m x2 minus x1, right? It's not y2 minus y1. It's y minus y1 is equal to m. This is x minus x1. This is true, right? This is true. What's wrong? Oh, you can't see. Oh, why? Yeah, right. Why our point? Yes. I write in our blackboard. Yes, you can't see. I don't know why. But here, yeah, you can see. So you don't know why. Maybe like this. Maybe I write like this. Maybe Oh, now can you see? Okay, I can see. Right to left. Okay. I know why. Oh, we just review the point slope form. We just review point slope form. And we write this equation. This is a point slope form. This means if we know a fixed point and the slope, we can calculate the equation of this straight line. And next, we will learn the slope-intercept form. This means equation of a line can be expressed in various forms. Suppose we are given the slope m for a line and the y-intercept b, like this. This straight line, we have the slope. Slope is m, and this line have the y. This is called a y-intercept. This is b. This means the line intersects the y-axis at 0b, and then b is called y-intercept. Okay, as shown in figure 12, choosing a point is 0b as x1, y1. This means as a fixed point, right? And we can apply the point slope form. We know the point slope form, we can write is y minus y1 is equal to mx minus x1. Here, x1 is 0. Y1 is b. So we get the equation. This equation, y minus b is m times x minus 0. And then this can be written as y is mx plus b, right? And this is the lecture is called the slope-intercept form. Anytime we see an equation written this way, we recognize it as a line and can immediately reach its slope and y-intercept. Here, if we write as this form, the slope here, we can directly read this is m, right? And the y-intercept, we can directly get this is b, right? For example, when consider equation, here is 3x minus 2y plus 4 is 0. Then we can simplify it. From this, we know 2y is equal to 3x plus 4, right? And then we have y is equal to 3 over 2x plus 2, right? And then we know if anytime we see an equation written this way, this means y is mx plus b. This is we write is mx plus b. We can immediately reach its slope and y-intercept. So we can get the slope m is equal to 3 over 2, right? 3 over 2. And the y-intercept, this means b is equal to 2, right? B is 2. Okay. If we solve, this means we solve for y. We get y is 3 over 2x plus 2. And it's the equation of the line with the slope 3 over 2 and y-intercept 2. Okay, y-intercept 2. And now we will learn equation of a vertical line. It's like this, vertical line. Vertical lines do not fit within the preceding discussion since the concept of slope is not defined for them. Vertical line. Like this. X 0. Oh, no. There, with 0. The slope is not defined further, but they do have equations, very simple ones. The line in figure 3, here is figure 3, has the equation. Here, this is x is, equation x is 5 over 2, 5 over 2. Since the point is on the line, if and only if it satisfies this equation, any point in this line, we know the x coordinate is equal to 5 over 2. So it satisfies this equation. The equation of any vertical line can be put in the form at this k. For example, this k. So we write this vertical line equation is x is k. And for example, this is 3. We write this vertical line equation is x is 3. Right? X is 3. It should be noted that the equation of a horizontal line, for example, this line, we can write, if this is true, this is true. We know any points on this line, any point 1, point 2, this point, we have this point have the y coordinate is 2, right? So this line we can write is y is 2. This is a horizontal line. This means any horizontal line can be written in the form y is k. And any vertical line we can write in the equation is x is k. This is the horizontal line, this is the vertical line. This is any vertical line we can write. This is y is k. This means we have the equation of the vertical line, horizontal line, and also we learned any. This is not vertical line. This is not neither the horizontal line. This is mx plus b. Mx plus b. And then we learn the form. This is ax plus by plus c is 0. It would be nice to have a form that covered all lines. We know the slope intercept form. The slope intercept form we write is y is mx plus b. But in this form, we know the vertical line is excluded because vertical line we don't have the slope m. So here we want to find the equation that covered all lines, including vertical lines. Okay, so we consider, for example, here this is a line is point slope form, and we can simplify it as y is 5x minus 3. 5x minus 3. And for this line we can write this is equal to 1 minus 2 is equal to minus 4x minus 8. So we can write this is y is minus 4x minus 6, right? 4x minus 8. Y is minus 4x minus 8, right? This is point slope form. This is slope intercept form. This is a horizontal line, x is 5. this can be written how to write by taking everything to the left hand side or to the left hand side as follows. For example, this one we can write taking everything to the left hand side. This is 4x plus y plus 6 is 0. And this taking to the left hand side, to the left, we have minus 5x plus y plus 3 is 0. And this one you can write is x minus 5 is 0, right? And all are of the form here. 4, we know the convention is 4, so we write a general constant a, this is x, plus this is 1, a general constant we write b, plus this is 6, you can write a general constant c is 0. And here we can write, we do not have 1, but we can write it's 0 times 1. So this means b is 0 for this one, right? And for this one, we know a is minus 5, b is 1, c is 3, right? So all are of the form is ax plus by plus cz is 0. A and b not both 0. If
Ma'am,
a
I
and
have a
b,
question. Ma'am, can I speak?
what's wrong? Yes, you can.
Laushi, I just don't get it. I just don't get it. Last 4 lines. You, yeah, right in. I just don't get it. Last 4 lines.
The last what?
Last 4 lines
This
are
one?
from minus 5x plus y plus 3. No. Last 4 lines you have written from minus 5x plus y plus 3 equal 0 from this line.
Oh, you don't know why this is 0
Yeah,
from this.
exactly, ma'am.
Taking everything to the left hand side. Right? Taking everything to the left hand. This is 1
Okay, ma'am,
minus
got it.
5x. Right?
Yeah, I got it.
So we just write minus 5x plus y plus 3 is 0. Understand? Hello?
Yeah, Laushi, I got it.
Okay. Let's continue. Now, we know if A and B are both 0, A and B both 0, we know C is 0. This is not a line, right? This is 0 is a constant. Just 0. So it's not a line. Right? So here, A and B, not both 0. Okay, not both 0. And we call the general line, we call this is the general linear equation. It takes only a moment thought to say that the equation of any line can be put in this form. Conversely, the graph of the general linear equation is always a line. This means if we write the equation like this, okay, and we know this equation, the graph of this equation is a general linear, is always a line. And any line can be put in this form. Any line, no matter straight line, vertical line, and any line can write the equation can write like this form. So this is called general linear equation. General linear equation. And now we will learn the parallel lines. This means two lines that have no points in common are said to be parallel. Have no points in common. Parallel. For example, the lines whose equations are y is 2x plus 2 and y is 2x plus 5 are parallel Because for every value of x, the second line, this line is 3 units. Is 3 units. 3 units above the first, right? This one is 3 units above the first. Here is finger 14. This is y is 2x plus 2. This is y is 2x plus 5. We have every value of x. Every value of x, we have this line is 3 units above this line. Okay. Similarly, the lines with equation. Minus 2x plus 3y plus 12 is 0. And 4x minus 6y is 5. 6y is 5 are parallel. Okay. To see this, we should solve each equation for y. We will write like this. Okay. To compare. Right? Okay. So each equation for y. This is, we should put it in the slope-intercept form. Here, this is the slope-intercept form, right? And this gives, for this one, we write the minus 2x plus 3y plus 12 is 0. We solve for y. Okay, we solve equation for y. We know 3y is equal to 2x minus 12, right? Solve it for y. Y is equal to 2 over 3x minus 4, right? And then the second, this one. Solve it for y. Solve it for y. We know 6y is equal to 4x minus 5. Right? 6y is equal to 4x minus 5. And we have y is equal to 4 over 6 is equal to 2 over 3x minus 12 over 6. Right? And we can find this is the slope-intercept form. Okay. We know. We can find, we write this respectively. Again, we find the slopes are equal. Slopes are equal. Slopes are equal. One line will be a fixed number of units above or below the other, right? Because they have the same slope. So the lines will never intersect. Right? Because here we know this line is 3 units above this line. So they intersect. If two lines have the same slope and the same y-intercept, then the two lines are the same and they are not parallel. For example, when L1, they have the y is mx plus b. And L2, the equation, they have the same slope. They can write y is mx, right? They have the same intercept, y-intercept. So, b are same. So this over here, apparently L1 is equal to L2. They are the same line. So they are not parallel, right? The same, just the one line, right? Not the two lines. Always summarize by stating right two non-vertical lines, because we will talk about the slope. So vertical line, they don't have slope. So we're stating that two non-vertical lines are parallel only if they have the same slope and different y-intercepts, right? Different y-intercepts. Because if they have same slope, same y-intercepts, they are the one line. So they are not parallel. So, if two non-vertical lines are parallel, if and only if they have the same slope and different y-intercepts. And two vertical lines are parallel if and only if they are distinct lines. We know. For example, here we have this is a vertical line, right? And this is another vertical line. If they are not the same, we can say they are parallel, right? They are parallel. So two vertical lines are parallel if and only if they have distinct lines. Okay? And from this, we know if we want to judge whether these two lines are parallel, we should find their slopes and compare, and we should find their y-intercepts. They should have same slope, different y-intercepts. Okay. Now we have concepts review. 1, 2, 3, 4. Maybe give you just 5 minutes. 5 minutes. 5 minutes to finish it. Learn. Okay. Quickly now. Hello, maybe hello, we can do it together, okay? Hello, students online, can you hear me? Hello, because I'm not sure. I'm not sure you can hear me. Yes, okay. Okay, we begin to explain them together. First one is the distance between the points -2, 3, and x, y is. What's your answer? Okay, what's your answer? The distance, which remember the distance formula, right, is equal to x plus 2 square plus y minus 3 square. I have the square root, right? Number one, maybe if you don't know, this means you didn't review what we have learned last time. Right? Okay. The second one, the equation of the circle of radius 5 and the center -2 -4 2 is. What's the answer? Is x what? Plus 4 square plus y minus 2 square is 25. Yes, maybe you can explain to them to get the answer. Okay. And the third one, the middle point of the line segment joining -2, 3, and 5, 7. Yes, right. It's equal to -2 plus 5 over 3 over 2. Sorry. And this is 3 plus 7 over 2. So it's equal to 3 over 2, 5. 5. And the first, the line through AB and CD has slope. A is not equal to C. Slope is D minus B over C minus A, right? D minus B over C minus A. Or we can write is equal to B minus D over A minus C, right? But it's not, this is wrong. It's not equal to D minus B over A minus C. This is wrong, okay? Any questions? Any questions? No? Okay, we continue. Okay. If no questions, we continue. Uh-oh. This is not homework, just the exercise. Maybe exercise. Maybe I think you can do all of them because it's just the same. This is center radius from the circle, equation of the circle. We just have done the same. Find the equation of the line through the points. Maybe 24. Give you 2 minutes. 2 minutes just for 24. 2 minutes, 24. Now, write it now. If you have finished, you can share your answer here. Let me see. See your answer. Okay. Maybe you can find the slope. Please tell me your slope is equal to. Oh, your slope. Oh, your slope is 2. This means slope is 7 over 5. Minus 5 over 4 minus 3. So it's 2, right? And the fixed point I choose 3, 5. So I will use point slope form. Y minus 5 is equal to 2 times x minus 3. Right. Okay. Are you right? Are you right? Yes, this is right. Okay, we continue, okay? If no problems, we continue. Now we will learn the concepts of mappings and functions. We know the definition of mapping. Let A and B be non-empty sites. For every x belongs to A, there is a unique y belongs to B corresponding to x, according to some determinate the f. The f is called the mapping of A into B, denoted by the right is f. From A to B. R we write f x to y, y is fx, x belongs to A. This means we can have bingo. Here AB to non-empty sites. For example, this is the site A. And every x, this every x belongs to A. There is a unique y belongs to B. Example, this is B, the site B, a unique y. Corresponding to x, according to some determinate the f. This means for every x belongs to A, there is a unique y belongs to B. According to x, corresponding to x, according to some determinate the f. So the f is called a mapping of A into B, denoted by B. And y is called the image of A, of x, under the mapping f, and x is the inverse image of y. Yeah. The site consisting of the image y of all elements x belongs to A is called the ridge. This means the ridge we write is denoted by like this. R we write like this, ridge. This is the image of y of all elements x belongs to A. So we can write FA is equal to, this is also a site y. Y have a factor is y is fx. Here x belongs to A. So this is the ridge of A. We should have a remark. A mapping is also called an operator. It's a mapping F. This means we can also call F an operator. If B belongs, is contained by R. Then the mapping R, this is from A to B, it's called a function. These are the real side. A real side, this is called a function. If A is equal to B, A is equal to B, then F is called a transformation under set A. This means we have A, B, they are the same sign. Okay, they are unique Y belongs. So this means F is called a transformation on the set A. If a mapping F maps every element of A into its cell, then F, this means this is A, F maps every element of A into the cell. For example, this is X, then we have F, this is a mapping F of functions. Let A and B to be to non-empty subsets of the real number set R. Then a mapping F is from A to B is called a function of a single variable denoted by F from X to Y. So we write Y is Fx, X belongs to A. Where here X is called independent variable and Y is called dependent variable. Fx0 is called function variable at x is 0, x0. And A, we call this is the domain of definition of F, denoted by the domain is df. And Fa is called range of F, denoted by Rf. Do you have learned the definition of function before? Okay. If you learned it before, maybe it's easier for you to understand. And we may think of a function as a machine. Okay, this is a function as a machine that takes as its input value x. Input x, and then produce an output. This is output fx. Each input value is matched. Each input value is matched with the single output value. This one has a unique output. This one has a unique output. It can, however, happen that several different input takes input values give the same output values. For example, this input is x1, input is x2. Different input values, but F is a machine. This machine produce same output, right? This is possible. Okay, this is okay. And we have a single letter like F. R, G, R, F is used to name a function. Then Fx read f of x, or Flx. Flx denotes the value that f assigns to x. The value f assigned to x. Thus, we have if f and x is x cubed minus 4. Then we have f2, f and 2 is f assigned to 2. So this means x is 2. It's 2 cubed minus 4 is 4. fa is a cubed minus 4. fa plus h is equal to a plus h cubed minus 4. Right? This is how to calculate the value of x at x. Now we will learn the domain and the range. To specify a function completely, we must state, in addition to the law of correspondence, the domain of the function. For example, f is the function defined by like this. With domain. And domain this minus 1, 0, 1, 2, 3. We have finger like this, finger. Then the range is input, if input is minus 1, we have output is 2, right? Input is 0, output is 1. Input 1, output 2. Input 2, output 5. Input 3, output 10. So we have the range is 1 to 5, 10. 1 to 5, 10. Right? This is range. The law of correspondence together with the domain determines the range. This means the domain and the correspondence determines the range. Determines this part. We have the mark. We know domain is specified for function. For example, I just write f(x) to the square root of x. No domain is specified for this function. We assume that this is the largest set of real numbers for which the law for the function makes sense. This means, although I don't give the domain, this is the largest set of real numbers for which the law for the function makes sense. So this means x is greater than or equal to 0. This is called the natural domain. This is called domain or domain. This is called domain or domain. 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 Numbers that you should remember to exclude from the natural domains are those values that would cause dividing by 0 or the square root of a negative number. This is we should notice dividing by 0 or the square root of a negative number. We should exclude these numbers. For example, we find the natural domains for A. Here is 1 over x minus 3. We know here x minus 3, and this is denominator. So this means x is not equal to 3, right? So exclude the point that makes the division by 0. So x is not 3. This means we must exclude 3 from the domain because it would require division by 0. Thus, the natural domain is x. X is not 3. That's like this. This may be read the side of x such that x is not equal to 3. The side of x such that x is not equal to 3. Okay, B. We have B. B, we have the square root, right? So this means 9 minus t squared must greater than or equal to 0, right? So we can solve this inequality. We have this t squared less than or equal to 9, right? We solve this equality. This means t squared absolute value less than 3. You know that? Because when t squared is t absolute values less than 3 absolute values. So we can have absolute values of t is less than 3. So we have a t must satisfy this one. And the natural domain is therefore the set of t's such that the absolute values of t less than or equal to 3, which we can write using interval notations i's. You can also write. And 3. Interval notation i's. Okay, and C. And like C. C here is equal to h omega. Is equal to 1 over, this is none minus omega square, right? None minus omega square. We must here, this chart is a denominator. So we must exclude or avoid dividing by 0 and square roots of negative numbers, right? So we must exclude, this means 9 minus x squared. It must greater than 0. It can't be 0, right? It must greater than 0. This means avoid dividing by 0 and square roots of negative numbers. We have, this is omega squared less than 9. C, we have, this means absolute values of omega less than 9. So we have omega belongs to, we said the interval notation is from -3 to 3. So the natural notation is interval -3 to 3. Okay, any questions? Hello, students, any questions? All clear?
No, ma'am. Clear. Ma'am, clear.
Okay, then we continue. C, any questions for C? All clear. Which part of C is not clear? Which part of C? See here, we know we should notice that 9 minus omega squared is not 0, right? Exclude or avoid dividing by 0. So this means omega is not equal to 3 and minus 3, right? It's equal to, right?